I welcome you to this Artificial Intelligence Concepts and Projects course. So in this video, we are going to build a face recognition system with Python. So we will be using a library called as OpenCV. CV means computer vision. So OpenCV is one of the widely used libraries for image processing tasks. So this face recognition system is one of the most advanced and widely used applications of machine learning and artificial intelligence. So you would have noticed this face recognition in your smartphones when the phone unlocks when it detects your face, and you would have also noticed it in Facebook when the Facebook system automatically shows the name of the person when you want to tag them in a photos. So all these tasks happen because of the face recognition algorithm. Okay, so in this video, let's build our own face recognition system. Okay, so there are three steps in this project. So the first step is we need to detect whether a face is present in an image or not. Okay, so that remains our first step, because if there is no face in it, there is no point in checking whose face it is. So first of all, we check whether there is a face in it or not. Okay, so the second step is we need to label the training images. Okay, so the training data is images for this project, so we need to label this data because it is a supervised learning algorithm. So hence we need to label the training images, and that remains our second step. Okay, so on the third step is we need to train the model and predict the faces. Okay, so once we label the training images, we load it to the model and we predict whose face it is. Okay, so this is the three steps involved in our project. Okay, so let's get into it right away. So I'll be using the IDE called as a Spider for this project. So this is the Spider IDE. So you can install it through a software called as Anaconda. So you need to install this Anaconda first. So from Anaconda you can download and install Spider. So Spider is one of the widely used IDE for Python. Okay, so there are several tutorials in YouTube on how to install Anaconda and Spider, so I won't go detail about it. So you can go and watch YouTube if you want to install it. Okay, so let's get started with the code. So you need to install the libraries NumPy and OpenCV for this project. Okay, so you can also view tutorials on how to installing it. Okay, so let's get started. So the first step is we need to import the libraries. Okay, so I'll first import OpenCV CV2. So CV2 is nothing but OpenCV. Then import OS. So we import OS in order to access the training images. So this is helpful for labeling the images. Next, I'll import NumPy as NP. So NumPy is useful for array operations and vector operations. Okay, so okay, let me comment here what this module is for. This module consists of the functions that we will use to recognize the face. So we will call this module in another file. Okay, now we need to define a function. So what this function should do is it should detect the face in the image, and it should return a array value of the location of the face in that image. Okay, so how we will do is, let me comment here, given an image, this function returns a rectangle for face detected. Grayscale image. Okay, so we will be dealing with the grayscale images. So define. Let's name the function as face detection. So we need to give a test image here, test image. So let me show the resources I have. These are the training images I have. So I have so you can see here I have made a folder called as training images, and I have made a folder named as 0, and I have my images taken from the webcam of my laptop. So it consists of around 350 pictures, so me watching on several directions and several positions. So we will train our model with this as our training data. So what we have to do is we have to label these images, and once we done that, we will test the model on this image. So you can see my image here. So what happens is we need to make the model to detect where the face is in the image and whose face is that. Okay, so this is the process, and you can see here I have a folder called R Cascade. So let me show what it is. So R Cascade is an XML file which consists of the feature for faces. So R classifier is basically used to detect some objects. Examples like it can detect some ball in it or a cycle or something like that. So these are pre-trained models which are encoded in a XML file. So they basically consist of the features of several objects. So we need to download the R Cascade file for the frontal face images. Okay, so you can go in Google and get this file. Just type R Cascade frontal face default.xml. Okay, so you can go to this GitHub link and you can download it from here. So this is a small file, but it consists of a lot of feature for the faces. We need to download this for detecting the faces in the image. So for this we'll be using a R classifier model. So yeah, so you can go on and download it from here. So you can go to this raw and copy the entire part and save it in an XML file, or you can download it from R Cascade. Yeah, you can. So as you can see, it consists of different object. It consists of for a tree and full body and stuff like that. So we need this frontal face. So you go on and download this XML file. So if you want, I'll also upload it in this video. Okay, so you need to download this XML file. So I have already downloaded it and I made a folder called R Cascade, and I have saved this file here. Okay, it's resume our coding part. So we need to detect the faces first. So this function takes image here, then we need to convert it into gray image. I'll store this in the variable called as gray image, which is equal to cv2 dot cvt color. So the parameters are, if you didn't get the parameters, you can search Google and you can find the descriptions in OpenCV documentation. So test image comma cvt, that's cv2 dot color, bgr to gray. So what this does is it takes this test image, which is a RBG image, which is a red blue green image. So and this image is converted to gray by applying this function cv2.cvt color. Okay, so that is this line of code. So because our model takes in only gray images, it doesn't care whether it's a color image or not. So it runs its analysis on the gray image. So we need to convert it to gray image, and I load the cascade R cascade file we have downloaded to a variable called as face R cascade. Okay, so face R cascade is equal to cv2 dot cascade classifier. Now we need to give the location of this file. So I'll go ahead and copy this location. So sometimes the backward slash won't work. So in Spider, so I'll change it to front slash for the location. I'll copy the image name, the file name. Okay, so R cascade frontal face default dot xml. So this is what we want, and what we are doing is we are loading the R cascade file. So then we need to detect the faces. So face is equal to this variable dot detect multiscale. So you can see here, so detect multiscale. So give that gray image, scale factor. So these are the parameters. As you can see here, we need to give the main parameters here. So scale factor is equal to 1.35. So what is this 1.35 is? So it consists of this rectangle, so for some definite dimension. So we need 35% of that dimension to reduce the size. So you can give any dimensions you want. So like for this around 30 to 35% it detects well. So you can go on and play around with this number and see what it actually does is. Then min neighbors gh bors neighbors is equal to, let me give it as 5. Okay, so this multiscale returns rectangles of where the face is. So what how this actually works is, so let's consider this screen as an image which has a person's image, and it need to detect where the face is in that image. Okay, so consider here is a person, so this part consists of their face. So what this detect multiscale does is it makes a rectangle of some definite dimensions. Okay, let's say this is in this dimension. So this rectangle goes on and scan throughout this screen, so and sees where the probability of a face is more in this image. Okay, so that's what it does. And what this minimum neighbor is, so we may get a lot of false positives where the model may predict that there is some face in this part. Okay, so for neglecting it we need to specify some false positive here. You can go on and give different numbers and see what result you are getting here. So what happens is, so let's say that this part I mean like there is a face here. So near the face you will get the probability of face more. So in order to get the correct place where the face is, we need to specify the min neighbors. Okay, so to neglect the false positives, then once we detect the faces, we need to return the faces, which is an array value, and the gray image. Okay, so this is the function for detecting whether a face is present in it or not. Then we need to make the second function, which is to label the training images. Okay, give labels to training images. Okay, so this function takes a directory as its input. So define labels for training data, which is training images. So we need to specify the directory here. So once we implement this code, we will give the directory and the images path. So define labels for training images directory, and let's make some list here. Faces is equal to, we are making an empty list. We will append the images here. Okay, so gray image. So I made a list called as faces and face ID. This is also an empty list. Then we are going to make a for loop here. For these are the variables path, subdirectory name, subdir names, then file names. These are for the 300 images I have shown you. Consist of three variables. We are making three variables called as path, subdirectory names, and file names. In os.walk directory. Okay, so this is why we imported the library os. Now we are making another for loop inside this for loop for detecting that images for file name. In file names, this file names variable is here. So in file names, if file name dot starts with dot, which means the root directory, we need to neglect that because we don't need it. So that's why we are putting it. So we will just print skipping the system file, so we don't need to mess with that, so we will just skip it. Then we just give a continue function here. Now we need to give the id, so id is equal to os.path dot base name path. So what is this base name is? So you can see here I have stored the images in the folder named as 0. So this 0 acts as the labels. So this 0 is called as the base name. Okay, so we need to extract this base name and give it to give it as the label for all the images present in this file for all the 350 images. So hence we are just extracting this base name for labeling our images. Okay, so id is equal to os.path base name, and we need to give the path there, and image path is equal to os.path.join. We need to get the full path of the image dot join. So we need to specify, as you can see here, the path, and we will do it by giving path and file names. This is just for fetching the image path. Okay, so let me comment here. Then we need to, let's just print the image, the path and the image name, which is like print the image path is this. So we just need to print it, which is okay. So we just print the image path here. Then if the image is not loaded correctly, we need to return it. So now we need to do, what we need to do is we need to read this image. So that is done by OpenCV. So test image is equal to cv2.imread. So this imread function just reads the images. So the parameter will be image path. Okay. Now, so what this does is loads the image one by one so that it gets labeled. Okay. Test image. Now we need to make an if condition. If test image is none, which means if it's not read correctly, we just need to print that it is not loaded correctly. So it's none. Just go ahead and print. Image not loaded properly. You can just continue after it. So what happens is, once this is done, this for loop goes again and get the next file. So next image file, and the next image file gets labeled. So that is why we use this part. Now we need to detect the faces from it. So what we actually do is we use this function again here. Okay, so detect the faces. So now we need to get that what should I say, we need to get the bounding box of the space. So we need to detect where the face is there. So let me specify some variables xy wh, which are nothing but the coordinates of the rectangle. X comma y represents the xy coordinate of the first point, and w represents the width, and that represents the height. So if you have these values, you can say where the rectangle is in that image. So that's what we are going to do. Say xy wh is equal to faces rect 0. So this gives the coordinates of that rectangle. Okay. Then okay, we need to do another thing. So we need to get the rectangles first. So we just missed out something else. So what we need to do here is we need to specify this face rect first. Okay, see yes rect comma gray image is equal to face detection. As I told you, we are calling this function face detection again here. So detect the faces in each training images, so that we can train the model with the face we have detected from that image. Okay, so face detection. So we need to give the test image. So the test image is here, which is read by CV2. So test image. Okay, so let me comment here. What we are doing is calling the face detection function to return face location in each images. Okay, so now if it consists of more than one face, so we need to remove it, because we are just working on for images which contains only one person or one face. So if length of this face rect. If it consists of more than one element, we just need to neglect it. So face rect is not equal to 1. Just continue. So why we are doing this is, since we are assuming only one person is there in the image. Okay, so that's the reason. So yeah, now we can do this part. So once we detect the faces, we need to return the rectangle, the bounding box values. Faces vector 0, ROI. ROI represents the region of interest, which in this case is the face. So region of interest gray. So yeah, it is a gray image. So ROI gray is equal to gray image. So this gives the location of the faces. Y is 2. We are just locating the value from that array, so that's why we are doing this. Y is 2, y plus w. W is the width. X and y are the coordinates of the rectangle in that image. So x is 2, x plus h. So this gives the part of the face in that image. Y is 2, y plus w. And x is 2, x plus h. What we are doing is cropping the region of interest, which is nothing but face location. Okay, so then we need to append this to the list we have created before. ASS dot append to ROI gray. So this is actually a list. Okay, so hence we are doing this. Okay, so faces rect. Okay, so just a spelling mistake here, so that's the error thing there. So faces dot append ROI gray. Now we need to append this to the face ID, the list which we created before. Dot append the int ID, which is the label. So here the label will be 0. So ID, int ID. So we are converting that string to an integer value, which is 0. Then we need to return the faces and faces ID value. Okay, so the indentations are very important. Return faces comma face ID. So as you can see, the faces is the list we have made here, and the face ID the list we made here. Okay, so this, okay, so as you can see here, so this part detects whether a face is present in the image or not. So with the help of the R cascade classifier, so you can see here the cascade classifier. So this is our first step, as I have explained you before. So second step is for labeling the training images we have. So we have those 300 training images. The more number of training images you have, the more accuracy you will get. So this function is to label these training images. So once this is done, now we need to train our model, which is a classifier model, to predict the images. So now we will do the function here. So below function trains the classifier using the training images. Okay, so def, we call this function as train classifier. Faces comma face ID So let's do the function here. We will load the classifier in a variable called as face recognizer. So there are a lot of models to detect or to recognize the faces. So we will be using an algorithm called as local binary pattern histogram. This is one of the very good performing model for face recognition system. So face recognizer is equal to, so we are loading the model in the variable called as face recognizer. This is equal to cv2 dot faces, cv2 dot face dot lbph. So you can see here face recognizer create. So this is the model we will be using. Okay, so face dot lbph face recognition dot create. So we have loaded this model. We need to train it now. So face recognizer dot train. We need to give that faces here. So these faces are the input, and the np dot array. So we need to convert this face id to a numpy array. Np dot array face id. So numpy, we will just give the numpy array as the labels to this model. So np dot numpy array face id. Okay, now it returns this model, return face recognizer. Okay, so now let's understand how this LBPH model works, which is local binary pattern histograms. So it generally returns the histogram values. So I have just took a blog which explains this model, so we can understand it from here. So as you can see, we will cut the images like this. Okay, so then we will take the about like 3 into 3 pixels. So we will get these 3 by 3 pixels for this entire part of the images. So you can now see this central pixel here. We need to convert this to binary. So you need to see around the pixels which are around the central pixel. So if the pixel value is less than the central pixel, so we need to put it as 0. So here 0, it is greater than the central pixel, we put as 1. So we will do for all those. So you can see here, now we will write this in binary. Once we have done it, we will write the central pixel in decimal. Okay, so why we are doing this, this gives the histogram of that face image. Okay, so as you can see, it gives the histogram like this. So once we have trained our model for this histograms, when a new image is given, it again do the same thing, like it analyze those pixels and find the histogram of that image and predicts whose image is that. Okay, so this is the working of LBPH. So if you want to have more detail about it, you can go ahead and search on internet. You can find a lot of explanations. Then we need to draw rectangle around that face. So this function is for that. Let me comment here. Below function draws a bounding box around the face. Okay, so let me define the function here. Define draw rect test image comma face. So we need to specify that rectangle coordinates, which is x comma y comma w comma h. W is the width and h is the height of the rectangle, which is the face. So we need to give this face is nothing but the numpy array of where the face is. So we will give the details to these variables x, y, w, h. So this draws a rectangle. So we use this function for the purpose, cv2 dot rectangle. So the parameters are the image, test image, comma x comma y, which are the coordinates of the rectangle, and x plus w comma v plus h. So this gives the complete rectangle values. So now we need to specify the color of the rectangle, so we can specify that by, so these are the encoded values for blue color, so 255 comma 0 comma 0, so you can use any color you want. And we need to specify the thickness of the box. Okay, now we need to put the text there, the name of that person in the image. Okay, so we will do this by this function, loop function writes the name of the person in the image. So we will specify this name before itself, so we need to specify the name of that person before. Once the training is done, it can predict whether it is that person or not. Okay, so we are using this function for that. Define put text, so this takes the test image as input and text, which is the name of that person, x comma y. Okay, so test image text comma x comma y, cv2 dot put text is the function. Need to write the text in the image, test image comma text comma xy, cv2 dot font. We are just specifying the font. We'll just do this duplex font, cv2 font duplex. To comma, which are the specification of the text, so it will also be in blue color, 255 comma 0 comma 0. So as you can see, these are the parameters which are the bottom left origin and line type, so those are specified by this 2 and 4 and things. Okay, so cv2 dot put text, so the parameters are test image text x comma y, cv2 dot font rc duplex 2 and 2. Okay, so we are done. So we need to specify the value. Okay, so let me give a recap of what we have did there. So we have just imported the libraries first. So as we have 3 steps, we are doing it here. So the first function detects whether a face is present in an image or not, so that is for face detection. The second function labels for training images. It gives the label by extracting the name from that root folder and gives the label to the images present in that folder. Okay, and the third part is classifier, where we train the model with the training images, with the faces on the training images we have detected from this part. So we are training the model, then we are making the rectangle like around the face, and we are putting the name of that person using this function. So we have basically like these 5 functions. So 1 2 3 4 5, yeah, 5 functions. So let me go ahead and save this. Okay, so now what I'll do is I'll make another file. So this is where we are going to implement these functions. So untitled py. Let me close this. I'll rename this file as so I'll read this file consists of the functions we have just made. So I'll rename this to face recognition .py. Okay, and I'll name this file as image testing. So we are going to test the faces in the image. So image testing.py, the same place it is there. Okay, so let me open the file we have made before, face recognition. So we need to, in this file we are going to call all the functions we have done here. Okay, so let's go ahead for that part. So we need to specify the test image and the labels and all the such things. So what I'm going to do is test this image which I have showed you. This is not in the training image, this one image. So you can see this image here. It doesn't consist of the name and the bounding box and such things. So it's just a normal image captured from the webcam. So what this program does, it draws a bounding box around the face and it writes the name of that person. So we need to give the name of the person here. So let me do it. We need to import the libraries which we have used before. So let me go ahead and copy that. Additionally, we need to import this file as a module. So that can be done as import. So the name is face recognition, import face recognition as FR. So let me abbreviate it as FR. Then need to get the test image equal to cv2.imread. Now we need to specify the location of that image I have just showed you. So this is the location and the name of the file is test.jpg. So I'll copy the location and the name of the file is test.jpg. So I'll replace this backward slash with forward slash. Okay, so face is detected, comma, gray image is equal to f4 dot face detection test image. So what is this? This is the function we used here. So you can see here face detection. So we are abbreviating this module as FR and calling that function face detection. So we just need to put a quote here for the location. Okay, so faces will be detected here and we will print the location of the faces, which is the numpy array. Print faces detected. Now what we need to do is we need to store this training information in an YML file. Okay, so by this you don't need to train this model every time. You just train this and save the training data, which means like you can save the model in an YML file. You don't need to do the training because it takes time. So we are going to save that to a file called as training data.yml. So faces comma face id is equal to f4 dot labels for training images. Which we have used here, as you can see. So the labels for training images, we need to specify the directory now. The directory is, so we are going to write the, what should I say, we need to give the directory of the training images. Okay, directory of the training images is face recognition training images. So I'll copy this face recognition. So need to quote it. Okay, so we have given the directory. Now we are going to fit this to the training data face recognizer, the model we have made before. Face recognizer is equal to for dot. We have made this model in the face recognition module. Train classifier faces comma face ID. Okay, that's cool. So you can this train classifier function is here. So you can see here so face and face ID. Now face recognizer dot write. We need to write a YML file which is the training data I've told you. So you don't need to do the training again and again. The training done and the parameters and the coefficient values will be stored in this YML file. You just need to call this file when you need to predict a new person's image. Okay, so face recognition dot write, and we need to give the location. So I'll give this location itself, this face recognition location. And we need to name the file which is training data.yml. Face recognition training data.yml, and this training data will be stored in this file. Now this you need to run this part when you are running the code for the first time. Okay, so I'll uncomment these lines when you are running the code from the second time. Okay, so what this means is you just need to run this 3 lines when you are running this program for the first time. So when you run this first time, this training data will be stored in training data. So then you don't need to train again and again the model. So every times you run, so you just need to comment these lines once you are running it for the second time. You just need to comment it like this when you are running it for the second, third, and the further times. Okay, so first we need to uncomment this and comment this line when you are running code from the second time onwards. Now you need to what you need to do is you need to uncomment these lines when you are running the code for the second times. So what this part does is it loads this training data, so that's why we are doing it. So uncomment these lines while running the code from second time onwards. Okay, first I'll comment this. Okay, so let's write the code first. We need to extract this training data YML thing first. Face recognition is equal to cv2 dot face dot the model we used before lbph face recognition create. Then face recognizer dot read. So we need to read this training data. So from second time onwards, you just need to load the file, and you don't need to train it every single time. So that's why we are putting this part. So for the first time, you need to comment this. From second time onwards, you can uncomment these lines and comment these lines. Okay. Now we are giving the name of the person. Name is equal to 0. The label we have given the label 0. So, I'll give my name here. So I have given my name. So this is basically the dictionary. 0 is the key and name is the value. So this 0 is nothing but our label. So let me comment about it here. Creating dictionary. Containing names for label. Now we need to make a for loop for face to detect it. For face in face detected. X comma y comma w comma h equal to face. Region of interest gray is equal to gray image y is to y plus h comma x is to x plus w x plus h. Okay, y is to y plus h and x is to x plus h. Label comma confidence. So this confidence value should be less. If the confidence value is less, it means our model is more confident that it's the name of that person. Okay, so this confidence value should be less for a correct predictions. So confidence is equal to face recognizer dot predict ROI gray. So what this part is, it predicts the label of the image. Here we have only one label 0. You can also train for multiple people. I'll just show you in the end how to do for multiple people. And now we need to draw the rectangle. FR dot draw rect test image comma face. This is the predicted name. For 0, it's this name, which is my name. We need to specify it here. Predicted name is equal to name label. So which means if the label is 1, if we specify for 1, it is some other person, it shows here. If it's 0, the label is 0, the name is corresponding name is this, so that's why. Now if the confidence is less, it should not print the name. Okay, for that, if confidence is greater than 35, so the confidence value should be less for correct prediction. So if it is greater than 35, so let me comment here. You should not print the name. We can print unrecognized or something like that. You can specify it if you want. Don't print the name. Okay, so you just need to continue. We need to put a text. Fr dot text Test image, predicted name, x comma y. Okay. Now we need to print the confidence and the label. So we print the confidence and label in the screen. Now we need to resize the image. Resized image is equal to cv2 dot resize test image, comma. We need to specify the size of the image because some images may be very large. We just need a smaller dimension of it. So let me give the pixel as 500 comma 700 pixels. You can give any pixels you want. We need to print the image and it's done by cv2.imshow. The name of the image, which is face detection, and resized image. cv2 dot wait key 0 to dot destroy all windows. So this our part is done yet. So just spelling mistake here, nothing else. So this is our code. So you can see we are just giving the test image here and we are giving the label here and confidence here. So we just now what we are going to do is test this test image. It should give the name. Let's see whether it works or not. So I'll go ahead and run this first. So there is no error in this. Let's see if it works or not. So this may take some time, okay, because it needs to train all those images. So it just labeling all the images. That's what it showing in the output screen. Once it's done, it predicts the test image. So let's wait and see what it's showing. So the more number of images you use for training, the more accurate your result will be. So try to use more images as you can. So if you want to also check for other person's image also, what you need to do is just go to this training images. So go to this training images. Just make another folder for the new person you want to predict the name. So let's say just put it or one or something like that. Not doing it because the process is going. So in that folder just put the images of that person, and once you have put it there, you just need to add their names here as like 0 is to the name, comma 1 is to the name of that person, and the rest of the part is same. It can predict for that person also. Like this you can predict for any number of people you want. Okay, so this is the workflow of this is. So that's why I told you don't need to train this every time. As you can see, it takes a lot of time. So you just need to comment this. So now the images and the training data is storing in this file. You just need to uncomment this and comment this, so it runs quickly. Okay, no wait key. We got some error. That's okay, I think. So actually this should be capital K. That's the problem. Let me close this. So once we have run this for the first time, I'll just comment this and uncomment this. This won't take much time as we are just loading this file. So yeah, so we have got the label and confidence as 20, as you can see here. So it makes a bounding box around the face, and it prints the name of the person here. So this is how the face detection system works. So this is, you can go on and run this code for yourself and see how this works. I hope you have understood everything. So if you are doing it for some other person, just add this stuff. So comma 1 is to say the person name is Jack, and run the code. What you need to do is you just need to make a folder here named as 1 and store the Jack's images or any person you want images there. Once it's done, it can predict for any number of people you want. So I hope you have understood the problem statement on the project here. So go on and try to do this project by yourself. So in the next part, we will see how we can predict the images with the face of the person in a real-time videos using webcam. Okay, so that will be the next project. So go on and try to implement this code by yourself and learn this. Okay, so I hope you understood everything. See you then. Bye.